Okay, this might be the most technical slide for the whole talk. So this is about the methodology really, but that's the whole idea about the approach. We have inputs for the methodology, and we have the outputs for the methodology. So the input contains three things. We have a set of workflows, W, and we have a restriction criterion, R, and we have a goal to achieve upon the completion of your workflows. For the outputs, it's actually a mapping from operation trace to a constraint. Let's go into details what this really means. So W is actually a set of workflows that you wish to run in parallel. So we want to study the behavior of running all the member workflows in W. We want to study the behavior of that, but as I said before, because we will suffer from a combinatorial explosion problem, so we do need a way to restrict what should be the subset of traces that we want to focus our analysis on. So R is simply a restriction criterion, and let's go to a little bit detail for the restriction criterion. What kind of criterion can we have? We can do projection, which means, okay, we have W, which is a very, very complex workflows. But I say, no. I only care about the event cancel. Actually, no, the other way. I do not want to consider those scenarios where cancel can happen, which means I want to consider all the successful scenarios, and I can just do a projection. You will see an example very soon. And this PU and CU standing for predicate use and computational use. For those of you who are familiar with the data flow testing technique, so these are about the attributes. Either you use the attribute for computational use, or you use the attribute for predicates. We'll also see examples of that. And these are the combinators for the restriction criteria. We can say, given a restriction criteria, I want it not to be the case, or I want both restriction criteria to happen at the same time, or I don't exist. Both of them must happen at the same time. Just one of them will be sufficient. So that's the language for the restriction criteria. And a formal interpretation for the restriction criteria is to say, I have a workflows, and I try to apply some restriction criterion to it, and the resulting set of traces are those that satisfy the restriction criterion. Let's just go back to the methodology. Right, so that's R, and so given W over here, which might have an exponentially large set of traces, we want to reduce its size by applying R. So this is, so this is what we will end up with. So we have W applied with R with the restriction criterion, right? Finally, the G. Well, G is simply any arbitrary predicates constraint that you want to specify. In the simplest case, let's say I only care about completion. I can just say true. Just establish anything you like, as long as you can establish something. If you can establish something, that means we complete for the whole workflows. Okay, just about the outputs. As I said, output is from trace into predicate constraints. So now, for any trace T in the domain of out, we actually give you a constraint to say, for T to establish the desirable property G, you must make sure you start with a state where out of T actually is satisfied. I'll give you an example for that as well. Such that if you start from such state, you can guarantee after finishing executing T, you can end up with a state where this G will be established. Okay? So this is the driest slide of the talk. So let's go very quickly to some case study. Right? We have talked about this already. So, okay. Final slides before I go to the case study. So this is a summary of the technical details, which I encourage you to refer back to the paper. I don't think I should really mention this in the talk. So we have a language for defining operations, and we have a formal language for defining operations. We'll see how formal it is. And we also have formal language for defining workflows, which will refer to those operations. And we have a systematic way of collecting what should be data usage for each attribute in each method, individual operation. And also, for each individual data usage, we want to make sure we calculate a corresponding constraint to make sure if you satisfy this constraint, it is guaranteed if you execute this method, the corresponding usage will be exercised. Right? And one very important thing to mention is this approach is applicable to design models rather than C# code or Java code, because in the model-driven development context, design models are an abstraction about your whole system, so they are not supposed to contain every detail. So this is quite important. So it will be feasible, in my case, to have a very exhaustive exploration of the design space, whereas it is not possible for very concrete Java code or C# code. Yep, for this talk, we'll demonstrate through a case study. And again, I encourage you to read the paper if you want to find out more about the details.